CCI Crash Course Instrumentation presents episode number 32, Chapter 10, Wrap Up, Hardwired Safety and Amps, Start Logic, Playlist, Instrumentation Fundamentals, Hook. If it will not start, that is your logic saving you. The smartest panels do not need software to be safe. With a few contacts, a coil, and clear prints, you can prove a system is ready, stop it fast, and keep it down until you say go. What you will learn today: a clean, start, stop, plus seal-in pattern, how to stack a series of permissive OK contacts where trips live, what a simple manual reset latch looks like, how emergency stops and safety-rated contacts fit in, and the control power hygiene that keeps everything predictable. Core pattern, 3-wire with permissives. Stop, normally closed. Overload contact, normally closed. Permissive block. Series OK contacts that are normally open. Start, normally open. Seal-in, auxiliary contact that is normally open. Coil. If any OK goes false, there is no start. If stop or the overload contact opens, the coil drops immediately. Normally closed versus normally open, you will actually use normally closed for safety critical proofs, so a broken wire creates a safe open circuit. Use normally open when you want a positive, healthy assertion, such as a valve, proof of open, purge complete, or suction pressure healthy hatch. Latched trip with manual reset, no software. Add a tiny relay named RAW. Wire its auxiliary contact that is normally open around a reset push button that is normally open to self-seal when a trip occurs. A trip opens the coil circuit and energizes a. After the fault is cleared, press reset to open the seal made by WOOM and allow a restart. Reserve this for investigate before restart conditions. Emergency stops and safety-rated contacts, high level. Emergency stop devices should open a dedicated safety path that is normally closed, which drops control power to the coils. Use safety-rated buttons and relays where required. They provide monitored contacts and fault detection. We are not substituting for standards. This is layout logic, not a design certification. Control power hygiene. Use a control power transformer with fuses on the primary and the secondary, and label the control voltage on the door. Keep the overload contact that is normally closed up front in every ladder. Bond and ground properly. Avoid shared returns that create mystery opens. Tag coils as normally energized or normally de-energized so operators know the run state. Use interlocks that are speed rated so only one reversing coil can energize. Mini case, blower with purge. Permissives in series. Purge airflow healthy, contact that is normally open. Suction pressure healthy, contact that is normally open. Discharge valve proof of open, contact that is normally open. Until all three are true, start does nothing. Trip sources. Overload contact that is normally closed. High vibration contact that is normally closed. Emergency stop contact that is normally closed. Optional latched trip. Low lube oil pressure with manual reset. Commissioning checklist you can trust. Meter every device. Confirm label truth. Normally closed or normally open at rest. Simulate each permissive. Prove the diagram matches reality. Trip the overload and verify immediate dropout and proper reset. Pull the emergency stop. Confirm coils, de-energize, and cannot restart. Try to defeat the logic, tape a button, open a wire, and make sure the system still fails. Safe. Common mistakes to avoid. Using all normally open permissives, so a broken wire falsely permits a start. Placing the seal in contact on the wrong side of stop, so the motor will not drop on stop. Latching every alarm, which creates nuisance lockouts and operator workarounds. Forgetting control power transformer, fusing and labeling, which causes mystery trips and damaged transformers. History nugget. Before programmable controllers, refineries and mills used relay logic to control valves, pressure and purge. That visible logic still prevents surprise starts and shortens troubleshooting today. Wrap up. You now have a fast, safe recipe. Start-stop plus seal-in, a permissive block, clear trips, optional reset latches, emergency stops that drop control power, and clean control power practices. Pair this with Episode 31's reversing interlocks, and Chapter 10's hardwired control toolbox is complete. Thanks. Special thanks to Tony Koophout and the open source community for the incredible free curriculum that powers Crash Course Instrumentation.